Today I want to show you the Creality Ender 6 3D printer and how I plan to use it to accompany my Arduino projects. And I'll show you some of the stuff that I've already printed. I printed this from Thingiverse, some successful things that I printed, and some not so successful things that I printed. It's definitely a work in progress, but let's take a look at it. Well, this is my first time buying a 3D printer. I know very little about them except for what I looked up online and watched other videos, other people that have done this for a while. This is the Ender 6, and it's a Core XY 3D printer. That means that it prints on a plane, much like a CNC machine, and the bed will lower as the object is printing. Right out of the box, there was a bit of assembly that went on, and all the instructions were pretty good. Everything fit, and you didn't have any screws with bad threads or anything like that. At least that wasn't my experience. The instructions were pretty straightforward, and again, if I can do this as being my first printer to put together, there's no doubt that most of you could put this together pretty easily as well. If you go to the website and check out the features, it says easy assembly and sturdy build quality. I would agree with that. It is solid once you put it together. If you look at the solarbiotics.com description, it says it has a Meanwell power supply, but if you look at the official Creality website, it says it has a Qinliang power supply. But if you look at other websites like 3dprintersonlinestore.com, it says that it just has a branded power supply. So I'm not sure if there's a standard one or what I have. You can also print using a number of different filaments such as PLA, TPU, ABS, and PETG. I'm really just excited about the PLA because it's mostly what I want to be doing. And it runs a 1.75 millimeter filament, which I got to tell you, I had some problems with it in the beginning. It would load fine at first, but then after a while it wouldn't feed anymore, so we'll talk about that in just a second. Now with this machine, I'm doing manual bed leveling with the paper underneath the nozzle to determine the height. Now for me, a first timer, it's pretty easy to do. I know exactly where the bed needs to be, and I kind of like it that way. Now your print size for this machine is going to be 250 by 250 by 400 or 9.8 inch by 9.8 inch by 15.7 inch, which is pretty big. The bed is carborundum glass, and it can be a little bit tricky to get your item off there after you printed it. I just use a scraper, the scraper that they provided. If there is a way that's easier for you, let me know in the comments below. I'm using the free stock filament that came with the machine, and I'm finding the best way to get that to stick to the bed is to heat the bed to 50 degrees and to wipe the bed down with isopropyl alcohol just before you start the print. And the best nozzle temperature for this PLA for me was 220 degrees. This is the bottom of a stepper motor that feeds the PLA filament through, and I was having a hard time getting this thing to spin. It would just click and click, and the only way to get the filament through was to manually push it through. That was smooth, but it just wouldn't turn, so I had to take this thing apart multiple times. You can see the screw there on the left. I had to twist it all the way up and extend that spring out as far as it would go. That black bolt too, also in the middle, I had to loosen that black bolt quite a bit, and now it seems to be spinning just fine, but it took a lot of work to get this to actually spin correctly. And I'm just noticing here that if you look close enough, you can see I really did a number on stripping these bolts, but I may have to replace those bolts in the future here, but it's working for now. Now I've done a number of prints so far, and I'm starting to notice this metal dust gathering under the gears of the stepper motor which feed the filament through that we just looked at, and it doesn't look like it should be like that. Does anybody else have this problem, or is this normal? I'm going to clean it up, but hopefully it doesn't have an effect on it long term. These are a couple things that I printed just right off the bat, right out of the box after I got it set up. From Thingiverse, I went and downloaded them and uploaded them to the slicer, the Creality slicer, and then put them on the printer and printed them. I'm very happy with the printing of this Batman symbol here. It prints very smooth and it's very accurate. I'm very happy with the way this came out. Here's another look at the print from another angle. And so this is from Thingiverse. This is a Batman flexible kind of articulating Batman symbol, which is pretty neat. This one fell off, but I mean, it still turned out okay. I printed this little thing right here. This is a screen holder for an Arduino LCD screen. It's for my 20 by 4 LCD screen, and you can see the back of it. It didn't print that well. As you can see, it didn't cover the top there. These little pegs have nothing to hold on to, which is a problem. I don't know what that is, and it's very weak on the base, and you can see it's cracking already, and I haven't really used it. But I do like the concept, and I may go in and play with it, maybe thicken it up a little bit, give it some more support. But it would go in just like this. It'd be just like that. So I do like the concept, and it is holding, but it's cracked. Maybe I'll reprint it. I do want one of these. I tried reprinting it. As you can see, it didn't turn out too well again, so I don't know what the deal is. So this is the third thing that I printed, and like I said, I printed this on Thingiverse, and I'll include the links to all these in the description. But this one actually turned out very well. It's almost flawless if you look real close to the edges. The only damage you see is on the edges from me scraping it off of the glass. That's still kind of tricky. I'll have to figure out a better way to do that. But and then right here, that's me. I gouged that right there and kind of bent this, but I didn't break it. You know, the texture is very very nice. So I printed the box and then these 4 panels, and I just glued those on. And then I'll put it looks like you can put one of those candles down inside of it, but I'll put LEDs in there and see how that looks. But the inside turned out really nice. The bottom turned out really nice. Of course, there's a lid that fits perfectly on the top. Here's a look at the box with an LED in it. I put a red LED in there, and it's just sitting on top of a breadboard here. That's all I've done, and I like the way the lines show up. I think it's a great design, and whoever put that on Thingiverse did a really good job. Here's the blue, which I think looks even better. I do like the blue color because it's not as bright. You can see those lines easier. But my favorite has to be the green. I do like the green color, and I just think they all look really cool. At this point, I've taken my Blender object and I put it into Creality Slicer to get the G file, which I put on this SD card. Put the SD card into this display panel here on the front, and it's very simple to navigate your way through the menus to start your print. I just basically go to print, select the file I want to print, set the temperature for the nozzle and for the bed, and then that's it. At this point, I've already manually leveled the bed, so everything's already set up. You can pre-set your nozzle for 220 degrees or whatever temperature you're going to run it at, but that's about it. One of the selling points for this printer is that it can print up to 150 millimeters per second. That's 3 times faster than the regular 40 to 80 millimeters per second. But in the manual, it recommends that you print at regular speed, which is kind of interesting. I haven't printed at the faster 3x speed yet, but when I do, I'll let you know how it turns out. I came across this publication in the International Journal of Environmental Research and Public Health. It's titled Characterization of Ultrafine Particles and VOCs Emitted from a 3D Printer. Scroll down here, you can read the abstract, but what I want to read is down here in the introduction. It is known that thermoplastic extrusion can emit various hazardous compounds into the air, depending on the material used. For example, polycyclic aromatic hydrocarbons, volatile organic compounds, and acrylonitrile. Previously published studies have proven that some materials used for 3D printing by the FDM method, including ABS, PLA, PVA, and HIPS, emit ultrafine particles and VOCs. The increasing number of hours of 3D printing in household and living areas raises the issue of possible emissions of UFPs and VOCs from printers that use polymeric materials. So it looks like using this in your house, especially in a closed-in area, could pose a bit of a health risk. And of course, there's much more of this that you can read, and I will include the link to this publication in the description below if you want to check it out on your own. There's all kinds of data on it, so be your own judge in that matter. So here's my setup, and as you can see, I've got the printer right next to my computer, which is right next to my workstation here, and I've got this open top printer, which I don't know what reasons the panels serve, since there are big gaps. You can see right here, it's not airtight, it's not anywhere near airtight, it's just enclosed but not really enclosed. So it looks like I have more work to do. I'm going to build an acrylic box to put this in. It might look a little weird, but at least I'll keep down emissions, and won't get people in the house sick, which is the most important thing. So I am still excited about printing for my Arduino projects. This is just a minor inconvenience, but let me know what you think, and thank you for watching, and I'll have more Arduino videos on the way.